welcome back, Stella. I hope you are doing well. Okay, today we are going to. I hope you did all these two remaining exercises. So today I'll basically do these two exercises, and I'll give you. In fact, you try. I hope you also try this. I'll give you hints on how to proceed here. So let's go. Let's start with this one, question 5. Indefinite. Let me go to a sheet of paper. We have question 5, exercises. Okay. The integral of 32 on 16 minus x raised to the fourth. Okay. Let me go here. So the integral of 32 all over 16 minus x to the fourth. 32 all over 16 minus x to the fourth dx. Okay, how are we going to integrate this? This is firstly equals to 32 into the integral of what? 1 all over 16 minus x to the fourth dx. Okay, now there's not a standard form which tells us how to integrate this. But what I can see under here is that I can simplify this 16 minus x to the fourth. Look at something. We see that 16 minus x to the fourth is the same thing as, can be written as 4 square minus what? Minus x square all that square. This is already a difference of 2 squares. So this will be equals to 4 minus x square into what? 4 plus x square. Okay, I can further simplify this one as this. I can write it back as 2 square minus x square into 4 plus x square. So this is already again a difference of 2 squares. So I'll write it back as 2 minus x into 2 plus x all into 4 plus x squared. So this implies the integral of 32 on the 16 minus x to the 4th dx will be equals to 32 into what? Integral of, I'll replace all of this by this. So I'll have dx here all over 2 minus x into what? 2 plus x into 4 plus x squared dx. Okay, how do I then proceed to integrate this? It's very simple. The way to integrate this, I will first need to express this, that is 1 on all of this, as a partial fraction. You understand? So let's proceed to that. Let me wipe this. So let's express 1 on the 2 into 2 minus x into 2 plus x into 4 plus x squared into partial fraction. Let's express this into partial fraction. So in partial fraction, 1 all over 2 minus x into 2 plus x into 4 plus x squared. To express this in partial fraction, this is a linear factor. This is a quadratic factor. So this will be identical to what? A all over what? A all over 2 minus x plus b all over what? 2 plus x plus what? This is a quadratic factor. So this will become cx plus d on what? x squared plus 4. Oh, sorry. Okay, now, so this implies 1 all over 2 in minus x into 2 plus x all into 4 plus x squared will be identical to what? So the LCM here will naturally be this. So all of this. So I'll have 2 minus x into 2 plus x into x squared plus 4. This divided by this, I will have here a into what? A into 2 plus x all into x squared plus 4 plus b into this divided by this, I will have 2 minus x into 4 plus x squared plus cx plus d into what? Into this 2 minus x into 2 plus x. Okay, now for this fraction to be identical to this fraction, both the numerator must be equal to this numerator and this denominator must be equal to the denominator. But the denominator is already equal to the denominator, so the only condition is for this to be equal to the whole of this. So this implies 1 will be identical to what? 1 will be identical to a times 2 plus x into x squared plus 4 plus b into 2 minus x into 4 plus x squared plus cx plus d into 2 minus x all into 2 plus x. Okay, now we have to find the constants a, b, c, d, a, b, c, and d. Okay, now look at something. Without even developing this, I know that this, if I equate this 2 plus x equals to 0, I will have minus 2. And if I equate this to be this 2 minus x to be equals to 0, I will have 2. You understand? Now, if I want to find, for example, a, if I want to find a, it simply means I have to eliminate this and this. I hope you understand what I'm doing. So, to eliminate this and this, I see that there is 2 minus x here and there is 2 minus x here. That means if I substitute 2 here and 2 here, all of this becomes 0 and I will be able to find a, because there will be only the remaining part will be this and this. The same thing if I'm to find b, if I'm to find b, the best thing to do is to substitute, is to eliminate this and this. How can I eliminate this? To eliminate this, I'll substitute x here by what? Minus 2 for this to become 0. And when I will substitute also minus 2 here, all of this will become 0. That will permit me to calculate what? A and b. And from there, I will develop what will be remaining. I will develop the remaining expression in order to find what? C, in order to find C and G. Okay, very good. Now, let me see something. Okay. Okay. But we cannot do the same thing for C to find C and D, because this cannot be eliminated easily. You understand? So you will be forced to develop, after finding A and B, we will come back and substitute the A and B inside here. Or after finding A and B, we will develop all of this. You understand? Okay, let's first develop it. Let's first develop all of this, and with the conditions x equals to minus 2 and x equals to 2, we shall first find a and b, and from there we shall deduce the other one. Let's first develop this. So whenever you are at such a stage, the first thing is that, first of all, so keep this important equation. You keep it. Now we can call, let's call this one, this equation, let's call this star. You understand? So whenever we will need it, we will come back and substitute things here. Okay, let's develop this. This implies 1 will be identical to what? If I develop this, I will have a into this times this, it gives 2x squared. This times this plus 8. This times this plus x cubed. And this times this, you have plus 4x. Very good. Plus b into what? This times this, I will have 8. This times this, I will have plus x plus 2x squared. Yes, this times this plus 2x squared. This times this, I'll have minus 4x. And this what again? This times this, I'll have minus x cubed. Very good. Now let's develop this. First of all, you know that this is a difference of 2 squares, so it's the same thing as 4 minus x squared. So I'll multiply this with this, so we're going to have plus this times this, I'll have 4cx. This times this, I'll have minus cx cubed. This times this, I'll have plus 4d, and this times this, I'll have minus dx squared. Okay. Okay, what I'll do is this. I'll take like terms and equate to those on the right side. So let's first of all take let's bring out the equations. Let's first of all start by taking terms in terms of x cubed. So in terms of x cubed, let's take terms in terms of x cubed. In terms of x cubed, on the right hand side we have 0, so this will be equals to what? In terms of x cubed, I'm going to have this a times this x cubed. I'll have this a times this x cubed, so this will make a, so I will have a here. Okay, let's first develop, in order not to confuse yourself, in order for me not to confuse you, let me develop this and bring like terms together. So this implies 1 will be identical to what? 1 will be identical to this is a, this is 2ax squared, this is 2ax squared, 2ax squared, this b 2ax squared plus 8a plus ax cubed plus 4ax plus 8b plus 2bx squared minus 4bx minus bx cubed. Okay, I'll add this other one, plus 4cx minus cx cubed plus 4d minus dx squared. Okay, now we shall equate like terms. So we shall have the following system. Let's take terms in x squared first. So I will have, on this side there's no x squared, so I'll have 0 being equals to 2a, where is x squared again, plus 2b, where are we having x squared again, minus d. Okay, these were terms in x squared. I'll call this, let me take the eraser, I'll call this equation 1, These are terms in what? X squared. These were for terms in x squared. Now for constants, there is a constant here, so 1 will be equals to what? 8a. 8a, let's look for constants, plus 8b plus 8b. Let's look for constants, plus 4d plus 4d. This will be equation 2. These were constant terms. Now we'll finish. Let's take terms in x cubed. So there's no x cubed here, so 0 will be equals to what? A, let's take minus b, minus b, minus b, minus c, minus c. Okay, this is equation 3. These were terms in x cubed. What other terms are they? Terms in x. So there's no term in x on the left side, so 0 will be equals to what? This will give 4a. 4a, let's go, minus 4b, minus 4b, plus 4c, plus 4c. What again? There's no more any other term, so this will be equation 4. So this was for terms in x. So let me rearrange it. Okay, this implies the 4 equations we are going to have. The first one will be 2a plus 2b minus d equals to 0. The second one, we have 8a plus 8b plus 4d equals to what? Equals to 1. The third equation is this one, a minus b minus c equals to what? Equals to 0. And the last one, the last equation is this is equation 1, equation 2, equation 3. Okay, the last equation will be 4a minus 4b. Okay, here we can simplify this equation and divide all through by 4. You understand? So let me simplify it. Let me take the eraser. So this will become a minus what? Minus b plus c equals to what? 0. So those are the 4 equations we have. So whenever you arrive at such a stage, you first develop this and find I decided to develop this because it will be very we cannot directly calculate this. So I developed this to have my equations. Then using this star, I'll first substitute what? I'll proceed by substituting certain values, like for example x equals to minus 2 to find b, and I will substitute x equals to what? 2 to find what? A, because when I substitute x equals to 2, this term will always be 0. X equals to minus 2, this term will always be 0. So let's go to the next page. So let's now find a and b. Finding a and b. Finding a and b. Let's find it. Let me go to the next page. Finding a, b, and a, b, c, and d. A, b, c, and d. Okay. When if you look at this, let me come back. From this equation star, this equation, when x, let's say we want to find a. To find a, we need to make this term 0 and this term 0. You understand? We need to make these two terms 0. So for this term and this term to be 0, what I will need to do is what? I will substitute 2 here and 2 here, 2 here. If I substitute, if I replace x by 2, this becomes 0, this becomes 0. Y here will be left with a. So when x is equals to 2, let's go. When x is equals to 2, I will not use the equations to find a and b because I can easily find them from the equation star. So from x equals to 2, what are we going to have? When x is equals to 2, when x is equals to 2, this term becomes 0 and this term becomes 0. So I'll be left with 1 being equals to a into what? 2 plus 2 into 2 square plus 4. So I'll be left with 1 being equals to a into 2 plus 2 into 2 square plus 4. So this implies 1 will be equals to what? This is 4. This is 2 square is 4. So this gives it 8 times 8 times 4 is 32. So I'll have 32a, implying a will be equals to what? 1 on 32. So we have already our a. Now let's find b. Let's find b. Let's find our b. So to find b, where is it even? This is it. This is our equation star. To find b, what am I supposed to do? I'm supposed to eliminate this term and this term. How can I eliminate this and this? It is by substituting here what? Minus 2, and a minus 2 here will also make this 0. So when I substitute minus 2 here, this becomes 0. This becomes 0. So I will have what? I'll have b into what? 2 minus minus 2 plus into 4 plus minus 2 squared. So this will be equals to, so I'll have when x equals to minus 2, 1 will be equals to b into 2 minus minus 2 into 4 plus minus 2 squared. So this implies 1 will be equals to, this makes 4, this is 4 plus 4, 8 times 4 is 32, so I will have 32b. This implies b will be equals to what? 1 on 32. Okay, we have already our a and b. Now we have to find what? C and d. To find our c and d, to find our c, c and d, we cannot use this star. We cannot use this equation star because there is no means by which we can have this to be equals to 0, this 2 to be equals to 0, and we'll be left with this. So the only way to find c and d is to use each of the equations that were given here, each of the equations. So these are the equations. Let's start by finding c. If you look at equation 3, from equation 3 we have a minus b minus c equals to what? 0. So we shall use equation 3. So from equation 3, we have a minus b minus c being equals to 0. This implies c will be equals to what? C will simply be equals to, okay, c will simply be equals to a minus b. This implies c will be equals to 1 on 32 minus 1 on 32. 1 on 32. So this implies our c is equals to what? 0. You have already c. Let's now find d. Let's find d. Equation d. Let's find d. 32. How can we find d? When you look at this equation, you have 2a plus 2b minus d equals to 0. So let's use equation 1. Equation 1, we have from equation 1, we have 2a plus 2b minus d equals to 0. This implies d will be equals to 2a plus 2b. So this will be 2 into 1 on 32 plus 2 into 1 on 32. 2 here one time, 2 here 16, 2 here, 2 here one time, 2 here 16. So this will be equals to 1 on 16 plus this will be equals to 1 on 16 plus 1 on 16. Yeah, that's it. So this implies this will be 2 on 16. So this implies our D is simply equals to what? 1 on 8. So we have already our A, B, C, and D. Now we shall substitute it in the integral we are supposed to do. Let me create a new page. This is 45, 46, 47. Okay, so let me go back to where we were. So our aim was to express what? This impartial fraction. Our aim was to express this. So our aim was to express what? Wait, let me see something. Our aim was to express what? This impartial fraction. Let me copy this. So I'm going to copy this. I'm going to copy this. Okay, let me copy it and go to the next page. So our aim was to express what? This impartial fraction. So let me write back this for x. So this was the partial fraction we're looking for. So I will just substitute. So this implies 1 all over 2 minus x into 2 plus x into 4 plus x squared will be identical in partial fraction to what? Our A was 1 on 32. Our A was 1 on 32. 1 on the 32 into 2 minus x plus B was 1 on 32. 1 on 32 into 2 plus x plus what is our C was 0 and our D is 1. Our D is 1 on 8. So we have 1 all over 8 into x squared plus 4. Okay. Now remember that our integral was this. Where is our integral? Our integral is this. There was a 32. There's a 32 that's outside here. There's a 32 that is outside here. So after expressing this in partial fraction, we're going to substitute it where? We come and substitute it inside here. So this will be 32 times what? The integral of all of this. I don't know if you are trying to get what I'm saying. So this will be 32 times the integral of what? All of this. So this will be equals to, so let me go to the next page. So this implies 32 integral of dx all over 2 minus x into 2 plus x, 2 plus x into 4 plus x squared will be equals to what? Note that this 32 will come in and multiply all of this. So I will simplify already this 32 with all what I'm seeing here. This 32 divided by this 32, the 32 will go. Do you understand? This 32 divided by this 32, it will go. This 32 divided by this 8 will be left with 4 on top here. So this will be equals to what? This will be equals to the integral of 1 all over what? 2 minus x dx plus the integral of what? 1 all over x plus 2 or 2 plus x. Let's write it back. 2 plus x dx plus what? We will be left, since 32 divided by this 8, there will be a 4 outside here, plus 4 into the integral of what? 1 all over 4 plus x squared dx. Okay, very good. Now you see that things are already very simple to integrate. To integrate this is very simple. This is a linear function. To integrate this is a linear function. And to integrate also this, you know how to integrate this, because this is exactly in the form 1 all over what? A plus bx squared. So our substitution naturally there, our natural substitution here will be what? Tan theta being equals to what? What will be in bracket square. So let's I'll take each of these integrals and calculate it. I don't want to write back all of this. So let me go to the next page. So let's first find the integral of 1 all over 2 minus x dx. I will advise you to always work like this. When there are so many integrals to calculate each of them, and then you will come and substitute your answer. So the integral of this will simply be equals to what? We know how to integrate the integral of 1 all over ax plus b dx. Very simple. It will be equals to 1 all over what? 2 minus x prime ln of what? The absolute value of 2 minus x. You understand? Okay. I'll not put a constant of integration here. Okay, let's call this C1 plus a constant of integration C1. We know that when I'll integrate all of them, their constants of integration C1 plus C2 plus C3 will add up to a general constant that I will call K. So there's no problem. I think you understand what I'm doing, because this is a constant, a constant of integration. This is a constant of integration. So all of them will add up to a general constant K. I hope you understand what I'm saying. So the next one, integral of 1 all over 2 plus x dx. This, let me simplify back. When you differentiate this, this will give, let me wipe this, I did not complete the answer. So this will be equal to, when I differentiate this gives what? Minus 1. So I'll have minus ln of the absolute value of 2 minus x plus a constant c1. Okay, when I integrate this, this will give me 1 all over 2 minus plus x prime ln of the absolute value of 2 plus x plus a constant c2. When I differentiate this, it is 1. So this will be equals to what? Ln of the absolute value of 2 plus x plus our constant c2. Now let's proceed to the integration of we have 4 times the integral of 1 all over 4 plus x squared dx. Okay, to integrate this, we know that this already resembles what? The integral of 1 all over a plus bx squared dx, with the only difference that at the place of a we have 4 and at the place of b we have 1. So to integrate this, we naturally know that the substitution here will be done, but the aim will be first to write it in which form? 1 plus something inside here, all that square, before doing the substitution. You understand? So I'll put it in this form. So I first need to create a 1 here. So this will be equals to what? This will be equals to 4 times integral of what? Dx on, I factorize 4. This will be 4 into 1 plus, since there was no 4 here, this will become 1 on 4x squared. Are you okay with that? Okay. So this will be equals to 4. Let me wipe this. So this 4 will cancel this 4. This will be equals to the integral of what? Dx on what? 1 plus 1 on 4x squared. X squared. Now, what are we supposed to do? We are supposed to bring this inside the x to have all that square. We are supposed to bring to raise all of this square. So to bring this inside the square, we use our technique we have been using. So this will be equals to what? The integral of what? Dx on what? 1 plus the square root of 1 on 4 all that square times x squared. So this will be equals to what? The integral of dx on what? 1 plus, I will bring, since they have the same power, this becomes x square root of 1 on 4, all that square. But the square root of 1 on 4 is the same as the square root of 1 over the square root of 4. Square root of 1 is 1 and the square root of 4 is 2. So this integral becomes, this will be equals to what? This will be equals to integral of dx all over 1 plus what? X on 2 all that square. Is that okay? Okay. Now, this is already in this form. Now we are free to do our substitution. So let tan theta be equals to what? X on 2. I know already that where I will see x on 2, I will replace by tan theta. But what will be dx? To have dx, I differentiate this implicitly. When I differentiate this, the derivative of tan is sec squared theta or 1 plus tan squared theta. Sec squared theta is the same thing as that. Since I differentiated this with respect to theta, I'll have d of theta, which will be equals to, when I differentiate this, I'll have a half and beside I'll put dx. So this implies dx will be equals to 1. Dx will be equals to 2 into 1 plus tan square theta d theta. Okay, let's now substitute everything here. So this implies the integral of dx on the 1 plus x on 2 square will be equals to what? Integral of, I substitute the top, which is dx, 2 into 1 plus tan square theta d theta all over what? 1 plus this x on 2 is the same as tan theta, so with the square this becomes tan square theta. You see that this and this goes, so we'll be left with the integral of what? 2 into the integral of d theta, which is equals to theta plus a constant of integration c3. But recall that our theta was equals to what? Pardon, our tan theta was equals to what? X on 2. So this simply implies theta will be equals to what? Arctan of what? X on 2. So it implies the integral, this integral we were finding, this integral, so it implies 4 into the integral of dx all over 4 plus x squared dx, all over 4x squared will be equals to what? The integral of this will be arctan of x on 2 plus constant of integration c3. Now, since we have already everything, already, let me put do the small error. Okay, since we have already everything, where is even that page? Okay, we have already everything. So we have already this integral, and this integral. So let's just go here and substitute everything. This, and this. You understand? So the integral we were asked to find was the integral of 32 on 60 minus x cubed. So let me go back to this. So it implies the integral of 32 on what? 16 minus x to the 4th dx will be equals to what? I substitute the first integral. The first integral is integral of 1 all over 2x minus 2 minus x dx, which gave minus ln of 2 minus x plus, which gave minus ln of 2 minus x plus a constant c1, plus the next one gave what? It gave ln of 2 plus x plus a constant c2, ln of 2 plus x plus a constant c2, and plus this last one, which is arctan of x on 2 plus a constant C3. These three constants, they are all constants, so we shall group them under a general constant. You understand? So this will be equals to what? And look at something. This one and this one. We know that ln of A minus ln of B is equals to what? Ln of A on B. So ln of this one minus ln of this will be ln of what? 2 plus x all over what? 2 minus x plus this one arctan of what? X on 2. Now these three constants, we shall put a general constant k, where k belongs to what? The set of real numbers. So the integral of 32 on 16 minus x to the 4th dx is equals to this. That's how you integrate it. So what can you notice about this integral we just did? You can notice that we ended up with three forms that we know how to integrate. This form, which is basically the integral of what? The integral of 1 all over ax plus b dx. We know how to integrate this. And what do you notice also here? We saw this at the beginning, this type of integrals, which is 1 all over a plus bx squared. And you basically see that we are basically applying what? Rules we've seen previously to integrate this. So what the lesson you can draw from this is that master everything that has been taught in all the previous video if you really want to be very if I would say, if you really want to be excellent at integrating functions. So that was all. This video is already more than 40 minutes. In the next video, I will stop the video now. I don't know if I'm to stop it or to continue. Okay, let's say I'll continue. Let me continue. Let's finish this last one. Let's finish this last one, this integral. Where is it? Okay, let's do this in the next video. Okay, see you in the next video. We shall do this one and I'll give you hints on how to proceed about these ones.